Hello, this is Andy Miller, and I'm here to talk with you today about a contest that the Davidson Soil and Water Conservation District sponsors for all sixth graders in Davidson County. The topic for the contest is Water, the Cycle of Life, and it is an essay and computer designed slideshow contest. We're going to jump right in and start with the essay contest. And to begin telling you about the essay contest, let me make sure that we're all clear on what the difference is between a report and an essay. Most of you have written numerous reports through your school career, and those are just a collection of facts and presented in a formal manner. But an essay is a little bit different in that it's a short piece of writing that deals with just a single subject from your personal point of view. So an essay is different. You might use facts in your essay, and that would be good, but we want it to be from your point of view. Here are the rules for the essay contest. The essay must display the title, and it must show Water, the Cycle of Life for you to get full points. Your essay must be between 300 to 500 words in length. It must be your own work. Now, we hope you will do research, try to find some facts and some information for you to develop your essay, but it needs to be your own work. You can either type it or handwrite it on regular 8.5 by 11 inch paper. We do ask, though, that if you do it in your own handwriting, that you do it in ink. And then very important is that you identify yourself on the back of your essay. Your teachers will help you with the information that we need, but we basically need to know who you are, where you go to school, who your teacher is, so that if you are a winner of the contest, we can find you to get you the prizes. Here's how we'll score your essays. The content, or what you tell us about Water, the Cycle of Life, will count for 50 points. How you tell us, or your writing style, will count for 20 points. The organization of your essay, and what we're looking for there is a good introduction, a good body of the essay, and a good conclusion will count for 20 points. Neatness will count for 10 points. And there are a few things that we'll take points away for. If your essay is less than 300 words or more than 500 words, that will be minus 5 points. If it has the wrong title or no title at all, that will be minus 5 points. And if you use the wrong size paper, that will be minus 2 points. So let's go from the essay contest to the computer designed slideshow contest. This is new for us this year. So we're going to be learning a little with you as we go. So let's begin with the rules for the computer designed slideshow. Your slideshow must be no more than 15 slides of content. Now you can use fewer slides, but 15 slides with content are the maximum. And there's a specific order that we would like for your slideshow to be in. First, start with the content of your slideshow, and that's up to 15 slides. Then put in a blank slide, and then finish up with another slide that has your identification, your name, your school, your teacher, so that we can find you if you are the winner of the contest. So that really gives you up to 17 slides in total. Be sure to note that your slideshows must be created so that they're viewable as a slideshow on a personal computer. And if you're using Microsoft PowerPoint, the files need to be compatible with PowerPoint 2003. You can use audio. That is allowed. It's not required, but you can use it. You can also use slide animation to make your slideshow more interesting. But the use of videos is prohibited. Slideshows that use videos will be disqualified. If you're using sound or narrating your slideshow, it should not be longer than 5 minutes in length. And then we ask that you electronically submit your slideshow, and we'll give you an email address to submit those slideshows to. The slideshow must be created by you as an individual, and it must show a fresh new idea. So be careful and watch out for materials that are protected by something called a copyright. A copyright is something that is protected by United States laws that protects the authors and creators of original work. Those copyrights protect a particular manner of expression and idea, but not the ideas themselves. So to give you an idea about that, you can use cartoon characters in your slideshow, and maybe even comic strip fashion, as long as the ideas are yours. But if a classmate recognizes your characters as popular characters, then your work is being copied from the original artist. So remember to use your imagination, because your own ideas are the best, and that's what we want to see. Here's how we'll score your slideshow. The message that you give us about water, the cycle of life, will be 50 points. Something we call visual effectiveness, which just means how well you get the message across just by looking at it, will be 30 points. Universal appeal, which just means will everybody appreciate and understand your slideshow, will be another 10 points. And then how original your slideshow is, which just means how yours is different from everyone else's, will be the last 10 points. There are a couple of things that will be deductions to your score. If you violate a copyright, that will be minus 5 points. If you have more than the maximum number of slides, that's minus 5 points. If you exceed the maximum time limit, that's minus 5 points. And if you use video in your slideshow, that's a disqualification. Here's how the contest will work from this point going forward. We're asking each school to select no more than one entry per class from each contest. So one essay and one slideshow, no more than that, from each class to be selected to represent the school. Essays will be picked up on December 2nd at the school office, and the slideshows must be submitted electronically by 5 p.m. on December the 2nd to the email address you see there on your screen. And we'll announce the winners by December the 9th. We'll get a team of judges to come in, go through the entries that we get, and they will announce the winners on December the 9th. There are prizes for each contest. If you are the first place winner at your school, you'll get a trophy, and you will be entered into the county contest. At the county contest, the first place county winner gets a plaque and a $25 check. We'll also award your teacher a $25 check for helping you do your outstanding work. If you're the winner at the county contest, in either of those contests, your essay or your slideshow will be entered into what we call the area contest, where you'll be competing with the winners from 12 other counties. They haven't announced the prizes there, but last year I think the prizes were 25 for first, 15 for second, and 10 for third. If you win at the area contest, you're entered into the state contest, where the first place winner at the state receives $200 and the second place winner at the state level receives $100. We've been very successful in Davidson County here over the years, having essay winners at the state level, and we hope that at the end of this year we'll be able to present one of you with a state winning prize. So with all that in mind, if you have any questions now about the rules, the contest procedures, please be sure to ask your teachers. If your teachers can't provide you answers, your teachers will be glad for them to contact us here at the district office, and we'll be glad to answer your questions and get back to you as soon as possible with an answer to the questions. So with all that said, let's start learning about the water as the cycle of life. And I guess the first major question is, why do we refer to water as the cycle of life? Well, to me, it's pretty simple that it's the cycle of life because every living thing on earth must have water to survive. That goes from plants and animals to people to those microscopic organisms that we can't even begin to see without very powerful microscopes. So water is essential to life on earth. And that water is continuously being recycled. Just think about how we recycle water. As a person, we drink water and we take it in. That water that we take in is continuously being recycled. One of the ways that we recycle water is through a process called respiration. The water that we've taken in comes out as we breathe. And you can see this from this young fella as he's breathing out on a cool day. That cloud that you see in front of him is the condensation from the moisture in his breath. On a hot day, the water comes out of our body through perspiration. And then every day, regardless of whether it's hot or cold, we end up going to the bathroom through urination. So all that water continues to be recycled through the water cycle, and it's cleaned as it moves through that cycle. So let's talk about how that cycle works, how the water cycle, or another fancy term for it would be how the hydrologic cycle works. So here's kind of a drawing for the hydrologic cycle that shows the different stages within the hydrologic cycle. The basic things are you have places where water is stored, you have ways that water moves up into the atmosphere, how it stays in the atmosphere, how it returns back to the surface. Some of it will soak into the surface, some of it runs off, but all of it is continuously moved around in this cycle by the energy that is created by the sun. So let's go into that in a little more depth. Of course, the greatest place where water is stored is in the ocean. And if we look at what percentage of the Earth's water is stored in the ocean, we'll find that 96.5% of the Earth's water is stored in the oceans. Now, if we think about volume, scientists measure water volumes when we look at bodies of water as large as the ocean in cubic miles. So if you looked at the cubic miles within the ocean, it's a little over 321 million cubic miles. And if we look at all the water on Earth, it's 332,500,000 cubic miles. Now, a cubic mile is over 1 trillion gallons of water. So if we were to convert all of that into gallons, which is the way I have to think about it to get it to a measurement that I can understand, we have 326 quintillion gallons of water on Earth. So you can see that what that number looks like. And that's a huge volume of water. But the thing to remember is that within this water cycle, we're never creating new water. We're just having to reuse it. So it is a fairly fixed amount of water that we have available for use here on Earth. Now, that water goes from storage up into the atmosphere through two processes that change liquid water into vapor that can ascend into the atmosphere. The first one is evaporation, and the second one is transpiration. Now, quite often scientists will combine those terms, those two words, into a term called evapotranspiration that combines those words because it's hard to separate what is evaporation and what's transpiration. But the best estimates that scientists can come up with for the amount of water that's in the atmosphere that comes from evaporation and transpiration is that roughly 90% of the water in the atmosphere comes from evaporation, and the other 10% comes from transpiration. So let's talk a little more about what evaporation is. And evaporation is the process by which liquid water is changed into the gaseous state. And evaporation stops when the gas level in the atmosphere reaches saturation. That is the primary way that water goes from the surface to the atmosphere. Transpiration is done by plants, and it's the process of water loss from plants through a structure on a plant called the stomata. And stomata are small openings that are found on the other side of leaves that are connected to the vascular plant tissues. That's like our blood vessels. But the stomata and these vascular tissues move water and nutrients. And it depends on how humid the air is, how moist the soil is. Only a very small portion of the water that is used in transpiration is used to make the plant grow. Most of that water is just used to move the nutrients from the soil into the roots and then up into the various cells of the plants. It is also used within the plant to help keep the tissues from being overheated on hot days. That's what those stomata look like. They kind of, to me, look like little mouths, and those cells, you have really one on either side of the opening there, and they open and close to allow the gases and that water to move through the plant back out into the atmosphere. So if we compare evaporation and transpiration, or evapotranspiration versus precipitation, we find that it's about equal, the evaporation, transpiration versus precipitation on a global scale. But if we look at different areas on Earth, we find that more evaporation occurs over the oceans than precipitation, and more precipitation occurs over land than evaporation. Most of the water that's evaporated from the oceans falls directly back into the ocean as precipitation. And about 10% of the water that's evaporated from the ocean moves over the land and falls as precipitation. And that water falls as fresh water because when evaporation happens, the minerals, the salts, are left behind in the ocean. And just kind of as a curiosity, it's interesting to note that once a water molecule is evaporated into the air, an average amount of time it spends in the atmosphere is about 10 days. So, how much of the Earth's water is found in the atmosphere? It's really a very small portion. That would be 1/1000th of a percent. And we will find that as water vapor, and we can see it as clouds. And those clouds are just simply water vapors that have condensed on something called condensation nuclei. It might be a particle of dust or some other particle that's in the atmosphere. That precipitation that comes from the condensation is the vapor that accumulates or freezes on that condensation nuclei, and then gravity pulls it back to the Earth's surface. And when we think about precipitation, we're talking about rain, freezing rain, sleet, snow, or hail. And that's the primary way that water moves back from the atmosphere back to the Earth's surface. So when that water comes back to the surface, and we're just going to think about rainfall for the time being. So when you hear them report on the evening news that we had 1 inch of rainfall, how much does that really mean in gallons? So if we measured an acre is basically the size of a football field. So when we get 1 inch of rain on an area the size of a football field, that is roughly 27,154 gallons of water. That's called an acre inch. So 1 inch over an acre equals a little over 27,000 gallons of water. And on the 48 contiguous United States, or the continental United States, we find that we get enough precipitation in 1 year to cover the land surface to a depth of about 30 inches. Now, that rain comes scattered out over the year, scattered out over the continent, so that we don't see that kind of water standing at any one point in time. But if it all came at once, that's what it would be. There are weather factors that relate to and regulate the amount of water that runs off at the surface. Whether you get rain, snow, sleet, freezing rain, hail, affects how much runs off. How hard it rains, or the intensity of the rain, impacts how much runs off. The amount of rain, if we get a half an inch or if we get 10 inches, that makes a big difference. How long the period is that it takes to get the rainfall, or we call it the duration. So if the rain comes gently over a day's time, we get much less runoff than if we get all the rain in a half an hour's time. How wet the soil is has an impact on how much runs off. Wet soil will not absorb more water. Dry soil will absorb water and reduce the runoff. And then the conditions that affect evapotranspiration. If it's hot, cold, and whether the plants are actively growing will impact how much runs off. And then there are physical characteristics that affect the surface runoff. What is the land used for? Does it have a parking lot? Is it an open field? Is it a forest? Different kinds of plants or the vegetation influence how much runs off. The kind of soil you have, whether it's a very sandy or a very, very clayey soil, will either increase or reduce the amount of runoff. The topography, which is just the slope of the land. The steeper the slope, the more the water runs off. And then whether you have structures like ponds, lakes, reservoirs that might capture and slow that water from running off, have an impact on the surface water runoff. There are also some factors that we as humans impose on how much runoff happens. As we develop areas and put in what are called impervious surfaces. Impervious surfaces would be things like the roof on your house, your driveway, the roads that you come to school on, the parking lots. Those all reduce infiltration into the soil and increase the amount of runoff. When we clear away trees and grasses and remove the topsoil, that will also increase the amount of runoff and increases or decreases the time that it takes for that runoff, that rainfall, to reach our streams. And when we think about our streams, they make up a very, very small amount of the Earth's water. This is 0.2%. So streams, even though some of the rivers can look mighty big, they're really a very small portion of the Earth's water. A slightly bigger portion of the Earth's water storage is in lakes and swamps. And if we look at fresh water, that's the water that's not salty, it makes up approximately 3% of all the water on Earth. But lakes and swamps only account for about 0.3% of that. And we have two big lakes, one in Siberia called Lake Baikal, and the Great Lakes here in the United States, that together hold about 40% of the fresh water that's found in lakes and swamps. A bigger place where water is stored is in what we call groundwater. Groundwater is simply the water that has infiltrated and is stored in the cracks and crevices below the surface of the earth. And it begins as infiltration. That's just water moving down through the soil. And most of that is not like the picture you see here, where you've got a creek running into a cave that makes that water become groundwater. Most of it moves through the soil, as you see in this slide here. And as that water infiltrates into the soil, some of it goes back to the atmosphere as evaporation, but some of it soaks down through the soil. The first soil layer is called the unsaturated zone. In that zone, you have air mixed with water. But as the water begins to move deeper and deeper, it begins to fill in an area that we call the saturated zone, where the water completely fills all the openings in the soil. And the top level of that is called the water table. And the water table will have a little area above it that's called the capillary fringe, where water from the water table moves up because of capillary action into the water table. That's kind of like how a straw draws water up towards the surface. So that water moves down from the surface into the groundwater. And there are several factors that affect infiltration. Precipitation is the greatest factor. The soil is another factor that has a huge impact. How wet the soil is has an impact. The kind of plants that we have, or whether it's covered with impervious surfaces, has an impact. The slope of the land. On steep sloping land, very little water infiltrates into the groundwater. And then the amount of evapotranspiration has a minor effect on infiltration. That infiltration, though, is important to replenish something that we call aquifers. An aquifer is just a body of porous rock or sediment below the surface of the earth that is saturated with groundwater. And generally, there's enough groundwater there that we can use it to supply our needs. We put wells down into those aquifers to provide drinking water. But the water that gets to the aquifer takes a long time to get there, and it moves very slowly through the aquifer. So how much of this water on Earth is actually groundwater? Well, roughly about 1.7% of the Earth's total water is groundwater. And if we look at the fresh water, about 30% of the Earth's fresh water is groundwater, and that groundwater exists either from a few feet below the surface to a few miles below the surface of the earth. The bigger place where fresh water is stored is in our glaciers, ice fields, and snowfields, and they make up again about a little over 1.7% of the Earth's water. But it makes up about 2/3 or nearly 70% of the fresh water on Earth. And that ice that occurs as glaciers covers about 11% of all the land on Earth. And that represents the major portion of fresh water. Many states, particularly the western states, depend on mountain snowfields to store their drinking water for throughout the years. Places like California, Washington State, Oregon, all depend on those mountain snowfields to supply their drinking water. So here's one last look at how that water is distributed on Earth. If you start on the very left, the light green column shows all the water on Earth, with roughly 97 or 96.5% of the water on Earth being found in the ocean, and then another roughly 3% being found as fresh water. So if we take just the fresh water, that little slice off the top, and made a new bar graph with it, we could divide it up where most of it is found in the ice caps and glaciers. I told you earlier, roughly 70%, with roughly 30% being groundwater, with a very small portion of that being surface water. So if we took the surface water out of that bar graph and made a new bar graph with just showing the surface water on Earth, you'd see that lakes contain about 87% of the fresh surface water that is liquid. Swamps contain about 11%, and rivers about 2%. Now, each of those is still huge volumes of water, but the point is to show you that of Earth water, very little of it is fresh surface water that does not have salt in it. So that water cycle we've covered fairly quickly covers a lot of different ways for moving the water around on the Earth. And the important thing to remember is that you've got two forces moving it. One is the energy from the sun moving it up into the atmosphere, and then you have gravity from the pull of the Earth pulling the condensation back to the Earth's surface as precipitation. So with all that in mind, what can we do to take care of this cycle of life? Well, number one is to begin using water wisely. There are lots of easy ways that you can work to save water around your home and in your community. One of the easiest things to do, and a good starting point, is to fix any leaky faucets and leaking toilets that you have in your house. Those can be great water wasters because they happen all day, all night, and even just a little drip can add up to thousands of gallons in a year's time. Other things like when you brush your teeth, turn off the water rather than letting it run. Keeping a pitcher of water in the refrigerator so that you have cold water without letting the spigot run for several minutes to get cold water. Taking short showers or shallow baths will also help to reduce the amount of water. Most shower heads put out about 5 gallons of water a minute. So when you take a shower, you're using about 5 gallons of water every minute that you're in the shower. Be sure to use the dishwasher and clothes washers only when you have a full load. And then do your best to not use your toilet as a trash can so that you can minimize the amount of flushing that goes on in the toilet. There are other things that we can do as community projects to help take care of this water cycle. Number one on my list is to prevent pollution, because pollution takes away a part of the fresh water that we can use. Now, some of that polluted water can be cleaned up, but very often it is expensive and maybe even very expensive to clean up the water. And it's better if we can prevent it from becoming polluted in the first place. Other ways we can help in our communities is to be sure to put trash where it belongs, or pick up trash if you see it in the parking lot or on the school grounds and put it where it belongs. Help your family recycle. Make sure that your car is not leaking pollutants onto the parking lots, because when it rains, those pollutants from your car end up in our water. Be careful to not dump leftover household cleaners down the drain, or paints or other chemicals from the house down the drain. They can be disposed of properly at the local landfill. And then another way to help protect the soil is to keep the soil around your home covered with plants or mulch. That will prevent erosion, which prevents sediment, which is our biggest pollutant in North Carolina. And it also helps that water to soak back into the ground where it can become groundwater again. Next on my list is to learn about where the water that you drink comes from. You might drink water from a well. When I was growing up, everybody that I knew had a well. But that's changed when Davidson Water Incorporated came in. It is a public water system that takes water from the Yadkin River and then distributes it throughout the county. If you live in the city of Lexington or Thomasville, there is Lake Tomalex where that water comes from. If you live in the southern part of the county, there's the Handy Sanitary District, which takes water out of Tuckertown Lake. So the water that we use here comes from the local water bodies that are close by, and we need to protect those water bodies. If we all work together, we can keep those rivers like the Yadkin River clean. We can keep High Rock Lake clean. We can keep Tuckertown Lake clean. We can keep Lake Tomilex clean. And that means that we have better drinking water in our homes. So, at home, what are some of the things that we can do? One of the things we can do is collect runoff water from our roofs through something called a rain barrel or cistern. That provides water that we can use for outside uses like watering our gardens, watering our lawns, watering the shrubs around the house, maybe even giving the dog a bath. You can build rain gardens, which are just little small areas that are lined with plants and mulch that help to infiltrate water into the ground so that it can be cleaned and be there for us to use in the future. You can use a compost pile, and with that compost pile you end up with a very rich organic material, plant and animal matter, that you can use to help improve the soil, which will improve how water soaks into the ground. Thinking about water into the ground, we can use mulches or ground covers around our home, whether they're plants or chopped up mulch, pine needles, all of those things that cover the bare soil, keep the runoff from happening and allow it to soak back in where nature can clean that water where we can use it in the future. Another thing that we ought to be doing is testing our soil before we apply nutrients to it. Fall is the time when many folks put out the fertilizer in our lawns. Springtime, folks are putting fertilizer on their garden, and the only way to know the correct amount to put out is to take a sample and send it to a lab for an analysis. That lab analysis can tell you the correct amount of plant food to put out, or nutrients, fertilizer. By doing that, we reduce nutrient runoff. It helps you produce more of whatever you're trying to grow, whether it's grass or tomatoes in your garden, and it helps save you and your family money. Too much fertilizer applied, whether it's in our yard, our gardens, or on our farms, wastes your money. It pollutes our water with nutrients. Those excess nutrients lead to algae blooms like you see in the picture there, and other aquatic weed problems. So testing the soil helps us to use just the correct amount of fertilizer to help keep our water clean. We want to properly irrigate. If you look at this picture, you can see that a lot of that water is ending up on the sidewalk where it's not doing the grass or the shrubs any good at all. So we want to be sure that we're properly irrigating. And one of my pet peeves is seeing people irrigate in the middle of a hot summer day. On a day like that, if it's hot, sunny, you see so much evaporation that your irrigation does very little good. So be sure you're being smart with your irrigation. We want to also be sure that we're applying pesticides correctly, whether they're to control weeds or insects. We want those pesticides to do the jobs we're asking them to do and not run off and end up in our water. On the farm, a lot of the things are the same as they are at home. We want to do soil testing on the farm. We want to keep the soil covered with plant material. We want to use proper irrigation methods and timings. And we want to apply pesticides only when they're needed and in the correct amounts. All of those things are going to help keep our water clean and help our water cycle function properly. There are also some other things that we can do on our farms, like grass waterways, which are basically creating roadways for the water to drain safely out of the field without polluting the water in the nearby streams. We can use strip cropping, which is using alternating crops within the same field to help filter out the water as it drains out of a field. We can use a method of planting crops called conservation tillage or no tillage, where we use a special planter that does a task where you have, this is called a coulter that opens a slit. This is called a disc opener. It opens that slit up a little wider. The seeds are dropped in there, the fertilizer and any other necessary chemicals are applied. Then you have a press wheel that closes up the track, and when we've done that, then you'll see a new crop like this corn growing right up through the old plant material that was left on the surface, protecting the surface from erosion and helping to increase the amount of infiltration. We can use terraces, which are basically embankments or dams that are built across the hillside to slow the water down and cause more of it to infiltrate. We can rotate our crops. In Davidson County, one of the most popular rotations is to start with corn. That would grow the first summer. When the corn is harvested, we plant a small grain like the wheat that you see in the middle. The wheat would grow during the winter, be harvested the next spring, and then we would plant soybeans like you see on the right-hand side that would grow that next summer, and we would follow up the next year with corn again. Each plant adds something different to the soil. Each plant takes something different away. That helps keep our soil healthy, which helps to keep our water clean. We also want to use proper animal waste management. That means collecting and storing the waste properly and then properly applying it, because the waste contains nutrients that can be used to help grow our crops. We want to manage our grasslands, the pastures and haylands to feed our animals, but if we manage that grass correctly, it can also help to keep our water clean and our animals healthy. Planting trees is a great way to help protect and improve this water cycle. Plant trees put roots into the soil. Their leaves intercept the falling raindrop, and they help to clean up that water greatly as it moves through the water cycle. On construction sites, there's some special methods that we use. Construction sites often create muddy water, and muddy water is water that is polluted by our #1 pollutant here in North Carolina called sediment. So we want to prevent sediment by using things like silt fencing, which allows clean water to leave the construction site and the soil to stay behind. We might use sediment basins, which are basically leaky ponds that allow the sediment to settle out and the clean water to move downstream. We might protect areas with rocks that are called rock riprap. That could be ditches, it could be steep slopes, but the rocks help to slow the water down so that they do not carry the soil particles down into our streams and our water bodies. We want to plant grasses, and helping to get that started is using something called mulch to help cover the soil, help get that grass when we seed it to grow there and protect the soil. So those conservation measures all work together to help control how rapidly rainfall runs off. That helps to increase infiltration. That helps to filter out pollutants. Those pollutants get trapped in the soil. It helps to prevent erosion and sediment, which is our biggest pollutant by volume. It helps to keep our streams and rivers clean. And it helps to keep the water cycle working for us. So what I want to leave you with is that water is the cycle of life. If you have questions, please be sure to ask your teachers, and if your teachers need to, please feel free to contact us here at the Davidson Soil and Water Conservation District office. Thank you for your time, and I hope you'll have a great rest of your day.